I welcome you for this presentation. In this presentation, we are going to discuss about random bit generation. This is the overview of this presentation, that is need for random numbers, then pseudo random numbers, then true random number generator, pseudo random number generator, then randomness, unpredictability, algorithm design, and summary of this presentation. So in this presentation, we are going to discuss about the random numbers. Mainly, the random numbers are used in the key generation process, because in the cryptographic techniques, we are mainly using in all the algorithms, we are using the key. So how to generate the key? So the key is made of some random numbers only. So how we are generating the key in this cryptographic technique, that only we are going to discuss in this random bit generation. So the need for the random numbers, that is a number of network security algorithms and protocols are based on the cryptography, and these algorithms are making use of the random binary numbers. So generally where we are using this random numbers means in the key distribution and reciprocal authentication schemes, we are using the random numbers. Then in a session key generation, that is the communication is happening for a specific period of time. In that case, we have to create a session, and in order to create a session, we need a session key. So in the session key generation also, we are using the random numbers. That generation of keys for the RSA public key encryption algorithm, and generation of a bit stream for symmetric stream encryption. So wherever the key is used, in all the places, we need a random number. So the random numbers plays a vital role in this cryptographic technique. So only we are studying about the random number generation process. And there are two distinct requirements for a sequence of random numbers. That is, one is the randomness property and another one is the unpredictability property. Let us see one by one. First is randomness, that is the generation of a sequence of allegedly random numbers being random in some well-defined statistical sense has been a concern. That is, we are generating a random number and we have to check whether the generated random number is having the randomness property. So how we are checking the validity of the random number with respect to randomness in this sense? There are two criteria to check the randomness. One is based on uniform distribution. Uniform distribution in the sense the frequency of occurrence of ones and zeros should be approximately equal in the generated random number. That is uniform distribution. And to validate based on the uniform distribution is very simple. Verify that whether the generated random number is holding this property, that is uniform distribution. That is approximately whether zeros and ones are used or not, that we can easily verify. Another property is independence property. Independence means no one subsequence in the sequence can be inferred from the others. In order to verify the independence property, it is very difficult. So how we are verifying the independence property in this sense? We are checking that whether the generated number is not independent or not. Likewise, we are checking. So if it fails in that, means we are telling that it is having the independence property. So in that way, we can check the independence property. So these two criteria, each and every random number generator must satisfy these two criteria. Next is the unpredictability. One is randomness and another one unpredictability. So these are the properties of random numbers. Unpredictability means the requirement is not just the sequence of numbers be statistically random, but the successive members of the sequence are unpredictable. That is, it can't be generated using some patterns. That is, first 10 bits are having one format and another 10 bits are having another format. Then next 10 bit is following the first block of 10 bit pattern, means the attacker can easily guess what is the key, what may be the key. Likewise, the attacker can easily guess. So statistically, we are not following any patterns in the random number. That is the unpredictability. That is, with the true random sequences, each number is statistically independent of other numbers in this sequence, and therefore we are calling it as unpredictable. And that is, the true random numbers have their limitations such as inefficiency. So it is more common to implement algorithms that generate the sequences of numbers that appear to be random, and we have to take care that opponent is not able to predict the future elements of the sequence on the basis of the earlier elements. That only I already told you. The generated random number must not follow any patterns, because if it is following any patterns, what happens? The opponent or the attacker will easily guess what is the key. So if the attacker is guessing, means we tell that our system is not secure, because it is not providing security. If the attacker can easily guess the key, what is the purpose of the cryptographic technique? So always the key plays a vital role in the cryptographic algorithms, and we have to follow that the generated key must follow the randomness as well as the unpredictability property. If it is following these two property, or it is satisfying these two property, then only we can use the key in an efficient manner in the cryptographic algorithm. So next is pseudo random numbers. You know what is pseudo? Pseudo means it is false. So we are pseudo in the sense here it is not statistically random, but it is a random number. We are calling it as a random number, but it is truly it is not statistically random. That is called a pseudo random numbers. So mainly we use pseudo random numbers in the cryptographic techniques. So cryptographic applications typically make use of the algorithmic techniques for random number generation, and these algorithms are deterministic. We can determine this numbers, and therefore they produce sequence of numbers that are not statistically random. Generally, we are the cryptographic algorithms are deterministic in nature, and they are using a pseudo random numbers. Pseudo random numbers in the sense they are not statistically random, but it seems to be random. So if the algorithm is good, the resulting sequences may pass many tests of randomness and are referred to as pseudo random numbers. Say for example, in the Miller-Rabin primality test, what we are doing, we are just checking that whether the number is prime or not. But while testing the primality, what we are getting, we are telling it is a composite number, and another case it is not. We are not telling it is a prime. It may be a prime number. Likewise, we are telling. Likewise, here also, the generated random number has to pass many tests, and it is telling that it is a random number. So statistically not random, but it is a random number. Likewise, it is passing some randomness test, and we are calling it as a pseudo random number. And here we are having three formats. One is the true random number generator, and another one is the pseudo random number generator, and another one is the pseudo random function. In the true random number generator, what we are giving as input means the source of true randomness. Source of true randomness in the sense some entropy source we are giving. Entropy source in the sense the value is generated from the physical equipment of the environment of the computer. Say for example, some mouse movement value, or some clock value, something like that. So some value generated using the physical environment in the computer, that only we are using a source of true randomness to the true random number generator. Then that value is converted to binary, and we are getting a random bit stream. And in this pseudo random number generator, we are giving the input as seed. Seed means it is an initial value, and that seed is generated using this true random number generator. Then we are generating the pseudo bit stream. Here we are having the up arrow. So each and every time that value again passed on to the deterministic algorithm, and again we are generating the pseudo random numbers. And in the pseudo random function, there, in addition to the seed, we are having context specific values. That is, we are generating a value for some specific purpose. So in order to create a session key for some specific purpose, we are generating a random number. That is the pseudo random function. Let us see one by one. So first is the true random number generator, TRNG. This true random number generator takes as input a source that is effectively random. That is, the source is referred to as the entropy source and is drawn from the physical environment of the computer. That is, includes how it is generated. The entropy source is generated in the sense it is generated from some keystroke timing patterns, or some disk electrical activity, or some mouse movements, and some instantaneous values of a system clock. Likewise, any value can be used as a entropy source, but that value must represent the physical environment of a computer. And the source or combination of sources serve as input to an algorithm that produces the random binary output. The TRNG may simply involve conversion of an analog source to the binary output. In the pictorial representation, we have seen that. And the TRNG may involve additional processing to overcome the value in the source, that bias in the source. So in order to overcome the bias in the source, the TRNG will be doing some additional processing, so that it has to be the true random number generator will produce a random number which satisfies both the randomness property as well as the unpredictability property. Next is the pseudo-random number generator. This pseudo-random number generator takes as input a fixed value called the seed and produces a sequence of output bits using some deterministic algorithm. And the seed value is generated by the TRNG, true random number generator only, and the output bit stream is determined by the input value or values, so as the adversary who knows the algorithm and the seed can reproduce the entire bit stream. So the main difference between this pseudo random number generator and the pseudo random function is based on the number of bits produced. That is, the pseudo random function produces a fixed length of bits, but in the pseudo random number generator it produces some open-ended bits. That is, the size of the generated key must be of any number, but in the pseudo random function we are generating a fixed length size of the value, random number only we are generating. So the different forms of the pseudo random number generator or pseudo random number generator, the difference we are seeing here, and the pseudo random function. So in the pseudo random number generator, here an algorithm that is used to produce an open-ended sequence of bits. That is, the size of the bits may be any number, that is open-ended sequence of bits. And in the pseudo random function, we are producing a pseudo random string of bits of some fixed length. So here the input to the symmetric stream cipher is a common application for an open-ended sequence bit. Here in the pseudo random function, examples are the symmetric encryption keys and nonces. So the key size, say for example, if you are using data encryption standard, you know the key size is fixed. So if you are using AES, the key size is fixed. Based on the number of rounds, the key size is fixed. So in such cases, in order to generate the keys and all, we are going in for this pseudo random function. Also to generate the nonces also, we are going in for the pseudo random function. These are some of the requirements of the pseudo random number generator. The basic requirement when we are going in for the pseudo random number generator or pseudo number function is used for a cryptographic application is that an adversary who does not know the seed is unable to determine the pseudo random strings. So if the attacker doesn't know the seed, then he can't find out the pseudo random string. So we have to always generate a number in such a way that the attacker can't guess the key. And the requirement for secrecy of the output of the pseudo random number generator or pseudo random function leads to specific requirements in the areas of, you all know the basic properties, that is randomness, unpredictability and characteristics of the seed. Let us see that. So first is the randomness. So the randomness means the generated bit stream needs to appear random even though it is deterministic. If it is can be determined, means also it has to be appear that it is a random. So only we are calling it as pseudo random. That is statistically it is not random, but it is a random. It seems like a random. There is no single test that can determine if a pseudo random number generator generates numbers that have the characteristic of randomness, and if the PRNG exhibits randomness on the basis of multiple tests, then it can be assumed to satisfy the randomness requirement. So only pseudo random, that is, it is passing many randomness tests, but actually it is not random. Statistically it is not random, but it is passing many of the randomness tests. Later on we will see the randomness tests. So this National Institute of Standards and Technology defined a standard, that is SP 822, that specifies that the test should seek to establish 3 characteristics. That is, always the randomness test has to pass these 3 characteristics. One is uniformity. Uniformity in the sense, you know that the number of frequency of number of zeros and number of ones must be approximately equal, that is uniformity. Then scalability, and if you want to extend the size of the random number means also it has to be possible, that is scalability, and it has to maintain consistency as well. So these are the three characteristics that a randomness test has to pass. And this SP 822 lists 15 separate tests for randomness. But here we are just discussing about only 3 tests, and totally 15 tests are there. So whatever the random number generated has to pass some of the randomness test in order to be used as a key. So here one is the frequency test. Frequency test means the most basic test and must be included in any test tube. The purpose of this frequency test is to determine whether the number of ones and zeros in a sequence is, this one we already discussed, is approximately the same as would be expected for a truly random sequence. And another one is the runs test. This test focus of the test is the total number of runs in the sequence, whether the run is in uninterrupted sequence of identical bits bound before and after with a bit of the opposite value. And the main purpose is to determine whether the number of runs of ones and zeros of various lengths is as expected for the random sequence. So always all the tests are coming under this category only, that uniform distribution and independence category we have already discussed. So based on that the generator number has to specify those properties. Next one is Moore's universal statistical test. The main focus of this test is the number of bits between the matching patterns, and the purpose is to detect whether or not the sequence can be significantly compressed without loss of information, and a significantly compressible sequence is considered to be a non-random number. So these are the 3 tests. In addition to these 3 tests, some more 12 tests are there in SP 822. Next is the unpredictability characteristic. That is, a stream of pseudo number should exhibit 2 forms of unpredictability. One is the forward unpredictability and another one is the backward unpredictability. Forward unpredictability means from the seed to the next stream of bit, whether we can predict or not, whether it is unpredictable or not. Likewise, we have to check. That is the forward unpredictability. Backward means from a set of from a bit of stream of bits to the seed, whether it is unpredictable or not. Backward process. Generally, how we are producing from the seed, it has to pass some, it has to be from the that is entropy source. We are creating a seed using this 2 random number generator. Then what we are doing, that seed is passed as input to the deterministic algorithm. Then we are generating a pseudo random number. So there we are generating some stream of bits. So from the generated stream of bits, is it possible to unpredict the seed or not? That we are testing. That is the backward unpredictability. So forward unpredictability means if the seed is unknown, the next output bit in the sequence should be unpredictable in spite of any knowledge of previous bits in the sequence. Forward from seed to the next. Backward the stream of bits to the seed. The backward unpredictability means it should not be feasible to determine the seed from the knowledge of any generated values, and there is no correlation between a seed and any value generated from the seed should be evident. Always whatever the value in the seed, that is also a random number only, the seed value as well as the generated key value, there is no correlation between these 2 values, or whatever the value sequentially we are generating, for each and every value there may not be any correlation. That we have to check. Then only it is easy, then only the attacker can't get the or gets the key value. So that is very, very important. So this is the unpredictability concept. And each element of the sequence should appear to be the outcome of an independent random event whose probability is 1/2. So 50-50% is there. The same set of tests for randomness also provides a test of unpredictability. So we have mentioned that 15 different tests are there for randomness. So for unpredictability also we have to perform some test, and the generated random number has to pass the test. Then only we are using it as a key. The seed requirements, that is the seed that serves as input to the pseudo random number generator, must be secure and unpredictable, and the seed itself must be a pseudo random number random number that we already know, because the seed is generated from the true random number generator. So the seed is also a random number only, pseudo random number only. Typically the seed is generated by the true random number generator. See here in the diagram, the entropy source, how we are generating it is that value we are getting it from the physical environment of the computer, that is some based on some mouse movements, or from the electrical equipment, or based on some clock values. Likewise we are getting some value from the physical environment of the computer, that is passed as input to the true random number generator, and we are generating the seed, and that seed is passed to the pseudo random number generator, then we are getting the pseudo random bit stream. So the next is algorithm design, that is we have to use these things in different cryptographic algorithms, and whatever the algorithms we are having is purpose built algorithms, that is algorithms designed specifically and solely for the purpose of generating pseudo random bit streams. So there may be algorithms that only generate pseudo random bit streams. So that is the purpose built algorithms. Then we are also having algorithms based on existing cryptographic algorithms, that is cryptographic algorithms commonly used to create pseudo random number generators include symmetric block ciphers, asymmetric block ciphers, then hash functions and message authentication codes. All these cryptographic algorithms, that is 3 broad categories of cryptographic algorithms, later on we will be discussing. So at that time you will understand how these algorithms are generating a pseudo random numbers. So these algorithms, that is purpose-built algorithms or cryptographic algorithms, can also be used to generate the pseudo random numbers. So in this presentation we have discussed what is the need for random numbers in cryptographic techniques, then pseudo random number, how we are generating the pseudo random number, what is a true random number generator, then pseudo random number generator, and pseudo random function. What is the difference between pseudo random number generator and pseudo random function? That is based on the number of bits generated or sequence of bits, that's the only difference. And we have seen 2 important properties of a random number, that is a randomness property as well as unpredictability, and how based on what type of algorithm these pseudo random numbers are generated. For that we are having 2 different algorithms. One is the purpose specific algorithm and another one is the cryptographic algorithms. Thank you.